హలో సార్ వినిపిస్తుందా సార్? కంప్యూటర్ ఆడియో. सर ये सिस्टम क्लोज मत करो कोई आता है स्पीकर हो सर यो सर स्पीकर हां सर 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 స్మార్ట్ సార్ ఇక్కడ గంట సరే సార్ తర్వాత అసలు ఏం చేస్తారు సరే సార్ స్టార్టింగ్ సార్ వస్తుంది సార్ 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 ఎవరో సార్ మనిషిని ఎప్పుడు అదే ఎన్నిసార్లు అంటారు వాడు అయిపోయిందా అయిపోయింది సార్ అయిపోయింది ఆయన ఫస్ట్ టైం ఉంటాడు సార్ పంపిస్తారు సార్ ఏం చేస్తారు సార్ సరే సార్ పైన రికార్డింగ్ అప్లోడ్ చేసాం సార్
ఉపేంద్ర
సార్ గుడ్ ఆఫ్టర్నూన్ సార్ చెప్పండి సార్ శివరాజ్ సార్ గుడ్ మార్నింగ్ సార్ గుడ్ ఆఫ్టర్నూన్ సార్.
గుడ్ ఆఫ్టర్నూన్. నన్ను కోర్స్ చెయ్యి
సార్ పార్టిసిపెంట్ సార్ సార్ చేస్తున్నా కోర్స్ చేయాలా సార్?
కోర్స్ చెయ్యి మరి.
చేసాను సార్.
ఒకసారి వాట్సాప్ లో మెసేజ్
సార్ ఓకేనా సార్? పెడతాను సార్ పెడతాను సార్.
స్వయం మిల్క్ ది వర్చువల్ ల్యాబ్ విజిట్ స్టార్ట్ అవుతుందని చెప్పి
సార్
నేనైతే రెడీగా ఉన్నాను. మీ ఇష్టం, మీరు ఎప్పుడు స్టార్ట్ చేయమంటే అప్పుడు స్టార్ట్ చేస్తాను.
సార్ పెట్టాను సార్, ఒక్క నిమిషం సార్.
ఇప్పుడేనా ఆన్ చేసింది? వర్చువల్ ల్యాబ్ అని చెప్పు. సోయా మిల్క్ ప్లాంట్ వర్చువల్ ల్యాబ్. సోయా ప్లాంట్ వర్చువల్ ల్యాబ్ విజిట్ అని పెట్టు.
ఓకే సార్. సోయా
సోయా మిల్క్ ప్లాంట్
సార్. ఓకే సార్.
వర్చువల్ ల్యాబ్ విజిట్.
వర్చువల్ ల్యాబ్ సార్.
వర్చువల్ ల్యాబ్ విజిట్.
సార్
అవి కూడా పన్నీర్ కూడా పైన పెట్టానా? పన్నీర్ కట్టు పైన పెట్టు.
ఏ సార్ పన్నీర్?
లేదు నేను ఇక్కడ చెప్తున్నా. లేదు
సార్
ఇక్కడ ల్యాబ్ లో చెప్తున్నా.
సార్
సిద్ధార్థ్ సార్ ఉన్నారు లైన్ లో?
సారు అదే ఈరోజు సార్ ఉందంట కదా సార్, వేరే దానికి సెషన్ స్పీకర్ అంట కదా సార్. సార్
యూట్యూబ్ లింక్ పెట్టావా?
పెట్టాను సార్.
ఉపేంద్ర
సార్ చెప్పండి సార్.
ఇప్పుడు ఇది నాది వీడియో ఒకటే కనబడుతుందా?
కనబడుతుంది సార్.
ఫుల్ స్క్రీన్ కనబడుతుంది కదా?
ఫుల్ స్క్రీన్ కనబడుతుంది సార్. కనబడుతున్నారు సార్.
2-3 minutes లో స్టార్ట్ చేద్దామా?
సరే సార్, ఓకే చేద్దాం సార్. అవునా సార్? ఒక 5 చేద్దాం సార్. సార్ 2 minutes చేద్దాం. ఇంకా పార్టిసిపెంట్స్ వస్తారు సార్. 23 అయినా సార్ ఇప్పుడు.
Sir, Kapil Pandey, sir, you raised your hand, sir, in doubt, sir. Sir, Kapil Pandey, sir, you raised your hand, sir, in doubt, sir.
I think by mistake.
Sir.
Okay, Upendra, we'll start.
Sir, okay, sir. Sir, okay, sir.
Okay. Part of this workshop, we planned 3 virtual lab visits. Out of 3, this is the first virtual lab, soya milk plant. Why? Because all our knows from 2015 onwards, education institutions not producing degrees. We have to mold the students as entrepreneurs, not as job seekers, job creators. That is our ACT motto. According to that motto, incubation centers, we have to establish the incubation centers. So from mechanical side, we selected the one good field, major field. I already explained in last session also. Dairy industry is the major driving force industry. So heavy employmency we can achieve by the dairy industry. So direct milk means again cow cultivation, so many points are coming to the picture. Alternate milk sources with high protein content is one of the best sources, soya milk. Already in India, and especially North India, utilization of soya milk started, and so from that soya waste also they are cultivating soya waste, means that pan, what is that we can call, I forget. For other food items also they are preparing from the soya waste. Soya oil already we are using soya.
Sir, sir, mute in, sir. Mute in, sir, me, sir. Sir, sure, sir. Mute in, sir.
Sorry, some other call came. So we selected soya is the soya milk production for our entrepreneurship opportunities. For that, we took the target. But soya milk production, one of the major drawback, only Sofit soya milk is producing. Entire India, majority of sales is Sofit soya milk only. But the cost of soya milk, we know Sofit soya milk cost per liter rate is coming 120 rupees. So we worked more than 1 year upon this develop the protocol because smell, one is odor smell is coming. We have to remove that odor smell, and taste point of view also. We have to bring the milk to nearer taste of the general milk. I think we succeeded in this journey. More than 1 year we struggled. So that's why our coordinators requested just virtual visit of lab will give more awareness regarding soya milk production. Now I'm sharing the main components. Then after individually I will explain. This is the small blower, not blower, boiler. You can see 4 liters steam it can generate. Now you can see the pressure of the boiler also. It is 1.5 to 2 bar pressure. Generally, more than 2 bar, 1.5 bar pressure steam we are sending to the grinder and the cooker. This is small boiler only we connected, and this is the grinding and cooking unit. Now we poured the 2 kgs of seed, soaked seed. I will show the soaked seed more batch. This is the boiler. Grinding, grinding and cooking combinedly we are doing. And then we started the grinder. In this model, the soaked soya seed, we are doing grinding. The time of grinding itself, by steaming, we are doing cooking also. By this, we can extract more juice from the seed. That is only the motto of this combined grinding and cooking. Some of the soya plants, what they are doing, first they are doing grinding and they are separating the milk. That milk again they are cooking. In this manner, the productivity of the milk is reducing. The energy required for the milk production may be decreasing, but the productivity of milk from the seed is reducing, and the protein levels of the milk also reducing. That's at least 7 hours. Generally, some of the plants they are maintaining at a higher temperatures, but you soak in normal temperature long time, you will get very good quality of the milk compared to short time hot water. These all are trial runners run by our last 1 year experience. Now I will show the seed. The soaked, this is the normal seed. Before soaking, I think it is the normal seed. Before soaking condition, this is the seed. After soaking more than 8 hours, you see, cold water soaking we are doing, how much absorption of the liquid is taking place, and how we can identify it is fully soaked or not. You can see it's seed center. There is no hard parts of the seed. Some of the seed I can show. All seed you can see. Totally soaked. So I want to produce the soya milk beans at least 1 day, 12 hours before I have to start my process. Not immediately. Today I want to produce the milk beans. So 12 hours before planning is required. Otherwise, if sudden milk preparation means hot water soaking we are doing, due to the hot water soaking, the soaking seed, you see the diameter of the seed and soaked seed. This much of quality soaking will not achieve by hot water soaking. If it is not properly soaked, means we can't extract juice. Because I want to extract the juice. Now this is the grinder cum cooker. See. Now, whatever the steam we are producing, I think is 1.5 to 2 bar pressure we are maintaining. In between the pressure, we are sending the steam. And our target here, so at least it has to reach more than 1 bar pressure. More than 1 bar pressure means around 110 degrees we are achieving the temperature. You can see the temperature of the grinder and juice. At least it will take for grinding cooking purpose 20 minutes time. 15 to 20 minutes time it will take. Once it is crossing 100, near 100 to 110 degrees temperature it is reaching, at time the pressures of the unit also will cross more than 1 to 1.5 bar pressure it will maintain. Then we will stop the steam supply. Then we will stop the steam supply the grinder and cooker. For this boiler also, general commercial gas connection only we are using LPG. Because per day maximum we are doing 3 to 4 shifts only we are running. Per batch, at least 4 batch per day we are doing. Per batch we can produce 15 liters of the soya milk by soaking of this 2 kgs of soya milk, soya bean. We can produce 15 kgs of soya milk. You can see. This is now we are mixing calcium lactate for making paneer. Once we got the milk, then we will make paneer. For cracking of the milk, generally in household utilities we are using citric acid. But due to the citric acid main drawback, one odor smell is coming. For removal of odor smell, at least 4 to 5 batches of cold water is required. Cold water ఉంటుంది కదా. మరి ఎలా? సో ఒకసారి చెప్పకూడదు, వాసన చెప్పకూడదు. So waste of cold water will take place if we are using citric acid. If we are using calcium lactate means it will add calcium to the paneer. Calcium is good for bone structure, for especially women more than 40 years who are eating paneer, our paneer, who are eating our paneer. It is added advantage to they are getting calcium medicine also for increasing bone strength compared to normal milk paneer. See, this water we are steaming, I think 92, in between 90 to 100 degrees. We are heating the hot water. In that hot water, we added calcium lactate. हमको check చేయకూడదు అంతే సార్ అంతే సార్ ఫస్ట్ మనం చూసినట్టు 2 minutes. Now we stopped the grinding operation. Now a roaring sound is stopped. Now only we are doing cooking. You see the temperatures now. Before starting, when we saw this one 20 degrees, now it is moved to the 40 degrees. Means steaming is now only steaming we are doing. By steaming we are doing the cooking. Cooking 2 methods. By flame we are doing the cooking means the odorness will increase. By steaming we are doing cooking means proper cooking of the entire product will take place. So effective mixing of means effective homogenization of the paste that soya paste will create. I think it will take 10 to 15 minutes time. Already 10 minutes completed. Next, after this, we will do vacuum suction. We are creating vacuum by using this vacuum pump. See, by this vacuum pump, we are creating the vacuum suction. Well, because we want to transfer this juice, soya juice, grinded and steamed soya juice to the second tank. Directly, it will not come. By creation of the vacuum suction only, it will come. For vacuum suction, two advantages. For vacuum suction, two advantages. We are removing the odor also. Material is coming by forcefully in the second tank, and water is going through the pump. Water is exhausted. So some of the water we are removing by vacuum suction only. If we are not using this method, the earlier method I mentioned, we are soaked the seed. After grinding, we are separating the okran and milk. At that time, for water removal, what they are doing is they are not doing anything. They are adding the flavors. We are adding flavors means once flavor, once temperature is increased means flavor will evaporate. Again, old water will come into the picture. We can't drink the milk. If this method we are using, majority of the water we can remove by the time of wax suction itself. You see the seed skin, you remove the seed skin after soaking. This seed skin for 2 kgs of seed, this much of skin we remove, not 2 to 4 kgs of seed. This skin directly we are giving feeding to the buffaloes or cows. Their milk productivity is increasing. The cows who are eating this skin, high protein skin, so their milk productivity is increasing. Same milk we can drink. So there is no wastage in soya milk plant. Two tanks, two vacuum suction tanks we connected because if some of the vapor, because some of the liquid, solid entirely will come into this place due to the vacuum capacity. Maybe some of the liquid is coming means we don't want to waste that liquid. If we are not arranging second tank means the liquid directly will go to the vacuum pump through the wastage. So second tank we connected means maybe due to the more vacuum pressure, whatever the vapors are coming, that vapors also will condense and we will collect milk from this second tank also. So zero wastage, our target is zero wastage. With zero wastage, we have to produce the milk, soya seed. After soaking, skin we are removing. That skin we are using for feeding of the cows or buffaloes, whatever it may be, animals. We are feeding to the animals. Human can eat, but at present we are not doing any trials on human being. We are free of cost. We are giving to the farmers. A small amount only, 1 kg, more than 1 kg. Out of this, more than 1 kg is there. Next, raise out. So you see earlier from 20 it started. Now we reached 45 minutes before. Now we reached 70. Once it is reaching nearer 100 crossing means 100 to 120, 110 degrees we are maintaining for effective cooking. So total steam is consuming 2 kgs of steam it is consuming for cooking of 2 kgs of soaked soya seed. can see. After this, whatever the calcium lactate mentioned, see, we kept mixing. Mixes. After deletion, while we are packing the milk, then also this is paneer stand. We'll pour the solid, whatever the whey, soya whey it is coming. At present we waste it, but soya whey have highest protein. We have to work out on soya whey also. At present we are not using whey because small amount we can't work. So here we are pouring. Then now after we will get in the press unit. Continuation gradual weight application. Paneer cake will prepare. I know that one entire preparation of two paneer I will show. This is after preparation of the paneer. This is a paneer cutting bed. 250 grams. Each piece contains 250 grams. One bed. It will produce 1, 2, 3, 4, 7, 15. 3 kgs of the paneer generally we are producing for batch. Batch means 2 kgs of soya milk we are soaking. We can produce 3 kgs of paneer. You see? So some of the flavors we are adding. It's not required. We are not in for like badam pal. We want to compete with the badam pal means badam pal or any other cool drinks. We can add these flavors. Generally, at the time of starting, we procured in 2000, I think, dates. Dates. What is the date? At present, flavor free soya paneer only, soya milk, soya paneer we are producing. And I think 2018, we bought samples only. The flavor companies are available in Delhi and Bangalore. They are providing free of cost all samples, 100 grams samples. You can see the samples. Which flavor is popular for in and our area? If we finalize it means, they will send that one, that flavor only 5 liters bag they will send. Otherwise, these all flavors will get free of cost. You can see kesar, mango, milk flavors also. Different milk flavors is there. Milk rich, vanilla, almond, malai, I think milk booster. In milk flavor itself, 4 to 5 flavors are available. If I want to produce cool drinks means I can use these flavors. Why? Because in cool drinks we are placing in fridge only. Later directly we are drinking. But hot purpose we are using means once we heated the milk means this entire flavor will evaporate. Then original smell again it is came to the picture. Better removing of odorness or smell. In the process, it is good for good marketing and also maintenance of quality also. Flavors means some chemicals we are adding, it is not acceptable. For preparation of badam pal, I think we added some vanilla flavor. Now we will go to the boiler section. What is the present condition of the boiler? Yes. Now we are reaching around 100 degrees. You see. Now pressure rise also initiated. Earlier 0 pressure. This 0 means 1 atmosphere. Now it is rising. So our steaming continues. Our steam also we are maintaining around, yes, కొంచెం పెంచకూడదు. Which bench? This is one of the packing unit. After production of milk, we will do general packing like milk packets. This is the thing. And for storage of this paneer or milk or chillu water, we are using fridge also. And for homogenization, separate flavor addition, we purchase one circulating pump for food grade circulating pump. At present, already mentioned, we are not producing any cool drink. That's why we are not using FSI. But facility is available only in fridge. పంప్ ఆన్ చేసిందా ఇది ట్యాప్ ఆన్ చేసావా ట్యాప్ చేసుకోవచ్చు సార్ and this all operate. We are using our water plant to the municipal from there to by pipeline connection. With a separate plant, we are not maintaining. The investment on RO is not a big thing. 50,000 we invested, we will get the RO plant, but maintenance is required. That's for college, entire college only place one RO plant is there. In the RO plant, we are maintaining engineer in RO plant. For entire hostels also one more RO plant we are getting. Only we have RO plants. From that RO plants only by pipeline we are getting RO water. The hardness of this water is 20 ppm, 20 to 30 ppm. Generally, for long-term storage of soya milk means distilled water, add chilled water. We can store internet connection. The rise reaching around 1 kg%. We stopped the heat supply to the boiler because we reached nearer pressure, more than 1 bar pressure. We reached this by steaming, then we stop the steam supply. Awesome. ఎక్కడ వచ్చేవారు ఈ సెంటర్ సార్ this entire plant we installed in our campus only, but somewhat not in
academic buildings. Separately for incubation, we constructed one building. And down floor we given to State Bank. Top floor we are maintaining for this like this incubation operations. So we are not disturbing students. The student group who are interested to work on this incubation activities, they will come separately. Because in we are adding in the academic buildings itself means it will create somewhat more disturbance to the student group. Now we stopped entire supply of boiler. Now there is no supply. Stopped entire supply of yes, because almost we reached our pressure. Even though now also we have to steam further steam supply is required also. Without any heating, we can supply the steam. Now we are about to start vacuum suction. This steam you can attend. And ఎంత మెయింటైన్ చేస్తున్నారు
ఇంతే సార్ మన వాళ్ళు ఓపెన్ చేస్తే గప్పుడు దిగి వస్తుంది సార్
ఇంకా ఆపేలా
సార్
ఎంత లిక్విడ్ ఉందా ఫుల్ చేసావు బాయిలర్ సరే స్టార్ట్ యువర్ వాక్యూమ్ సెక్షన్ So now we are doing vacuum section. The grinding is no. What was the లేదు కదా ట్రై క్లీన్ చేయండి దీంట్లో నీళ్లు వస్తున్నాయి రావట్లేదు. పైన ట్యాంక్ లో నీళ్లు ఉన్నాయి కదా. వాళ్ళు ఎందుకు ఆపావు? ఇది వాళ్ళు
ఇది హ్యాండిల్ లేదు సార్.
మరి దాంట్లో నీళ్ళు ఎట్టు వస్తాయి దానికి? చూడు. ఉందా? ఏం లేవా వీళ్ళ దగ్గర గన్నులు? గన్ను వైరు లేవా వీళ్ళ దగ్గర ఎక్స్ట్రా? అయిపోయిందా? ఉండు రాని. అయిపోయిందా? ఒకసారి ఇటు స్విచ్ ఆన్. X16 condensation. Yes.
Sir, hello sir. Sir, video రావడం లేదు సార్. సార్ వీడియో రావడం లేదు సార్. వీడియో
రావట్లేదా?
అవును సార్.
ఉపేంద్ర సార్ వస్తుంది వీడియో.
వస్తుంది సార్. ఓకే సార్. ఓకే సార్. సార్ సార్.
సోయా మిల్క్ పేస్ట్ వస్తుంది.
ఇప్పుడు వస్తుంది సార్. ఓకే సార్. ఇప్పుడు వస్తుంది సార్.
ఇప్పుడు వస్తుందా
సార్? వస్తుంది సార్. వస్తుంది సార్. ఓకే సార్. సార్ వస్తుంది సార్.
వస్తుంది సార్. శివారెడ్డి సార్.
This is the milk. Soya milk. Finally, we produced soya milk without any flavors. You can see the color also. Without any additives. Once we did the packing, extra packing means up to 6 months. Without any cold storage facility, we can store the milk. But some additives we are adding, but we are not disclosing that additives. Those are protein-oriented additives only. Once we get to the commercial market, we will write everything on the packet itself. How we gain that proteins, we will not write. But what are the additives we added, right? Because we are adding some badam also. Direct to badam seeds per 2 kgs. We are adding 50 grams badam seeds also. High protein soya milk we are producing. Our market price we targeted 60 rupees per liter with that much of high protein also. Local made. We don't have any transportation targets or we don't have any other targets. That's why we are capable to market our milk within 60 rupees. Now I will show how we are making paneer also. This is okran. Now we are pressing this okran. For the remaining juice, whatever the available, it will come. And also you may notice with only one worker I am doing this one entire thing. I am not using more labor also for my operation. He is my assistant for solar projects and also soya milk also. With one worker only I am using this milk and paneer. Anytime like this detergent is coming means it's a meaning it is a basic range, means a drinkable range. Our pH value is 7 to 8, like nearer milk, maybe nearer water. Also same pH value. In full-fledged commercial manner, like Sofit soya milk per day 10,000 we want to produce means full-fledged automation we can design. That expertise we have. That is, there is no issue for that. But initially we are introducing the public in health conscious point of view, not a drinking milk. Our batch this plant capacity 200 liters per day we can produce. This is our capacity. At present we are producing only 60 liters only. So less than 50% capacity only we are running our plant.
Now we are adding calcium lactate, cracking of the milk takes place. We'll get to 2-3 minutes means we'll get paneer. We are cracking milk at 70 to 80 degrees means we will get paneer. We will crack milk at 40 to 45 degrees means we will get cheese. But both are producing from milk only. Now we are producing paneer, not cheese. You see, and whey and solid is separated. Liquid and solid is separated. Proper cracking takes place. If this workshop in offline means at least we will take 2 days time for demonstration and training of the faculty. This is the walk run, you can see. This based on, by using this walk run, we can prepare chickies or any snacks or meal maker. Meal makers also preparing based on this one only. Or chickies, namkeen, everything we can prepare by using this walk run. Biscuits also, some of the companies manufacturing biscuits also. At present, we are not making anything. We are just giving to animals only, animal feeding. Now you see, you can visualize water and solid separation. Pure water and solid separated. Earlier milk, just small amount I removed. This is the milk we produce by calcium lactate cracking. We are producing the paneer. I already mentioned the main advantage of calcium lactate. We are adding calcium to the paneer. It is high level advantage for women. And second, odorness. There is no separate odorness because of cracking material. Odor free paneer. Upendra? Hello, Upendra.
సార్ చెప్పండి సార్. సార్ చెప్పండి సార్.
సెకండ్ స్పీకర్ వచ్చారా
సార్? సార్ ఇంకా లేదు సార్.
ఒక్కసారి కాంటాక్ట్ కాకూడదు.
సరే సార్, అయితాను సార్, అయితాను సార్.
నేను పన్నీర్ చూపిస్తాను, చూపించిన తర్వాత
ఓకే సార్, ఓకే సార్, ఓకే సార్.
So solid liquid separation, one local made jolly. These all these equipments, small instruments, all designed and fabricated according to our. No standard material is available for soya making. Sir, third part. Do then tap it. This thing tap it. Let the maul tap it. Maul tap it. Kun pipe it. This pipe na orgo. Then tap it. A pipe line the extra man laga. So now we are removing liquid separately. Then you will get solid. Vasam volume use ఇంకోటి తీసుకో, అది బాగాలేదు. మీరు అయిపోగానే ఉతక్కపోతే కష్టం. ఈ నీళ్ళు వాటర్ We prepare separate washroom also for cleaning of these things because we want to maintain separate washing and cleaning also. That's it. Now you can see we are removing this cheese. This paneer way contains more protein food, but first we are adapting effective utilization of paneer, soya paneer, and soya milk. Once they got very good awareness of public of this region, is Andhra Pradesh, then we will start working on this paneer way also. Next start this. That will go change the room. ఒక బ్యాచ్ అయితే అది క్లోజ్.
दूर हो रहे हैं, गर्म पानी हो.
పట్టుకో గట్ట పిల్లల సార్ ఊరికే
చిన్నగా
तो किसी सामने को देखे सार को फोटो दिखे खड़ो खड़ो खड़ो
we are not separated that liquid before pouring. This means it will take more time and like this
बस देखेंगे सार
addition will not take place. Through this cloth also some of the material can leak. For that reason only before we are separating by SS steel jolly, by using SS steel jolly we separated liquids only. Now this cake, see, by equally pouring. Because for all pieces, every piece has to maintain 250 grams. So equal distribution of the mass is required. Equal distribution. Yes. Now we are closing this one for mechanical pressing. For this also, if large capacity means pneumatic pressing unit can purchase, but it is small unit, that's a manual pressing unit only we are using. దీని కింద పెట్టానా Now this is the mechanical press unit. Now we want to prepare effective bonding of all solid material. కొంచెం సెంటర్ ఇంకా ఇంకా చెప్పండి. Removing. At least ఇది క్లీన్ చేయలేదు. At least it will take 10 to 15 minutes. Suddenly we can't apply entire pressure. Stage wise pressure we are applying. After reaching steady state, again we are applying some more pressure for effective bonding. Yes. You don't want to apply more pressure. By free hand, how much energy it is possible to apply, that's all. And wait some time, again bonding will take place, again apply some more pressure. Like this, at least 10 minutes we are taking time. Again, now we started a second batch also. In the third, we are pouring the heat, liquid, and the boiler also. We started the boiler. మరి అంత గట్టిగా ఉందా? Yeah. Just we are removing the moisture, that's all. By pressing whatever the liquid is releasing, we are cleaning that liquid only. Water this bed with Anna. చాలు అది క్లీన్ చేసి అన్న నీళ్ళు తీసుకురా.
You can proceed. Defined manner. The testing of this whole sequence in the paneer is prepared by sense. They are finalizing paneer is prepared or not. So around 1 hour time it is taking to prepare 3 kgs of paneer. So 6 hours I am working means I can produce 24 kgs of paneer. Because 2 hours for cleaning and preparation is required. So 8-hour duty based on this instrumentation, whatever the capacity is available. With this available capacity, I am capable to produce 24 kgs of paneer.
హలో సార్ ఫణికుమార్ సార్ జాయిన్ అయ్యాను సార్. యాక్చువల్లీ పేరు అడుగుతున్నారు, సిఎంసి అనే పేరుతో జాయిన్ అయ్యాను. అది కొంచెం జాయిన్ అయ్యాను, ఇంకో వీడియో ఏదో నడుస్తుంది యాక్చువల్గా. సిఎంసి సిఎంసి సి యాజ్ ఇన్ క్యాట్ ఎంసి.
Sir, hello, sir.
Hello.
Hello, sir.
Yes.
Sir, sir, Kumar, sir. Sir, I made you cohort, sir.
Okay.
Just wait for 2 minutes, sir. It is going to complete, sir. Video. Sir.
Okay. Okay. Share screen.
I've been, sir. I know, sir.
అదే కావాలి. తిప్పది. చిన్నగా నీళ్ళు వేయాలి.
Okay. Hello.
అందరూ ఐదు రెండు
Yes.
రెండు ముద్ర ఫెయిల్ అయినా మాట్లాడి ನಾನು ಅಡಕಂತ ಮುಂದೆ ಹೋಗ್ತಾನೆ.
హలో.
Hello.
Sir, tell me.
Can you hear me?
Yes, sir.
Is the screen visible?
Sir, yes, sir. Visible, sir.
Okay. Then.
Sir, సార్ చెప్పండి సార్.
స్క్రీన్ లో ప్రెజెంటేషన్ వస్తుందా?
వస్తుంది సార్, వస్తుంది సార్.
ఏమైనా కట్ అయినట్టేనా ఏమైనా ఉందా?
ఏం లేదు సార్, పర్ఫెక్ట్ సార్.
ఓకే ఓకే. గుడ్ ఆఫ్టర్నూన్.
ఇంట్రొడ్యూస్ చేస్తాను చెప్పు.
ఓకే
ఉపేంద్ర.
సార్ సార్ చెప్పండి సార్.
ఐఎమ్ రెడీ. ఐఎమ్ రెడీ.
Yes. 1 minute. I think that Upendra, hello.
చెప్పండి సార్.
సరే స్టార్ట్ చేస్తున్నాను, ఇంట్రొడక్షన్ స్టార్ట్ చేస్తాను.
సరే సార్, ఓకే సార్, ఓకే సార్.
I think you participants are enjoyed the soya milk plant visit. Up to preparation of paneer cake we shown. If time permits, for next week also we will try one more time if you are interested. Now our speaker is ready. SVS Fani Kumar sir is BTech Mechanical Engineer from Jain to Hyderabad. MSc Research in Aerospace Engineering from ISC Bangalore. PhD from USA and postdoc from London and Canada. He is a scientist in National Institute of Ocean Technology, Chennai. He published more than 35 papers in referred journals and conferences, and also is a member of IEEE, OES, OSI, and some of fellow of Institute of Engineers also. With this small introduction, now I am handovering sessions to the Fani Kumar sir. Sir, now session is yours, sir.
Okay. Good afternoon and sorry for the delay. That is the first thing that I want to say. I want to thank all the organizers, including Siddhareddy sir, for giving me an opportunity to talk with you. I want to present something on what we are working and trying to fit into the renewable energy theme that was given to me. So I'll be talking in brief about some of the desalination plants that we are working on. Then I will also be working on talking about other research that we do at NIOT, especially that is being done by me and from my department. So this is the brief introduction of what I'm going to talk about. I would like the session to be interactive. If some of the viewers can have any comments or anything that they would like to cover within the purview that I just talked about, I'll be happy to present. So I just want some interaction with the audience, if it is possible.
Yes, sir, it is possible, sir.
Yes.
In between, they will raise the hand.
Okay.
And they will ask the questions.
Okay. Now, the way I want to handle this session is I'll be talking about 3 to 4 projects that we did. And I'll also be talking about the research possibilities, what are there. Typically, if the way we see it is, we studied so much, we have obtained so many degrees. I want to apply somewhere in the research. Okay, then what research can I do and how can I apply it in the field so that it is useful for the public? So I'll be talking about the application and also the research that we did and what are the perspectives in the overall. So this is the way I want to do it. Any comments?
Yes, sir. Go ahead, sir.
Okay. I'll be talking about, first let me introduce a little bit about National Institute of Ocean Technology. We do applied research for Ministry of Earth Sciences, Government of India. We are an autonomous body under Ministry of Earth Sciences. So we have about 10 departments within NIOT. We handle everything related to ocean and also some things not related to ocean also, because we have attained some sort of stability in that area. So we do some other research also. So I represent ocean structures and island desalination, which I will be talking about. We also work on energy and fresh water from the ocean, where we are dealing with wave energy turbines, and also current turbines, and also producing power using temperature difference of the ocean. I will briefly touch upon in my presentation on those topics. Apart from that, we work on technology where we can take equipment up to 6,000 meters depth in the ocean to do various activities. Like one thing is the ROV, remotely operable vehicle. If you can see the pointer in the screen, the pointer is pointing towards it. Basically, it is connected to a ship that launches this vehicle. It goes to the depth of around 6,000 meters. Then using a cable, I lower it. At that cable, at that depth, it has some amount of flexibility to roam around in that area and give me the what is it, camera of the entire seabed at that depth. Okay. Apart from that, it is also possible to make small connections, like there is a link and there is a chain. It can quickly connect that, so that using another rope I can pull it up, and after connection I can lift or lower the equipment that is connected. This is a remotely operable vehicle that can work at a depth of 6,000 meters. That is the thing. The top right figure that you see on the screen is a soil tester and a crusher and pulverizer mining machine, basically. It is also designed for a depth of 6,000 meters depth in the ocean. Basically, these two equipment that I'm describing are for ocean mining project, where India is assigned an area, fixed area in the southern Indian Ocean region, where the depth is around 6,000 meters. We have a mandate to develop these machines, then test it. After testing, we have to make it so up to that level where anyone can take and demonstrate the technology. Then after that, we can use it for testing various testing the soil quality at that depth, then collecting some samples and pumping it onto the ship. All these things are involved in the research that we are doing. So this is as far as deep sea technology is concerned. We also have a division that deals with ocean observations, where it is a direct application for the weather updates that you see on day-to-day basis in your TVs. So basically what we do is, any weather prediction, it is incomplete if you don't integrate it with the ocean conditions surrounding the country. So where NIOT comes in is we have something called as ocean observation buoys, BUOY, buoy. Okay. These things collect all the ocean surface temperature details. Yes, please. Hello. Hello. Yes.
All microphones.
If you have any question, please feel free to stop me. Okay, so I'll come to the weather buoy again. So basically, hello. these weather buoys collect data on the surface data of the ocean. We also have a wing where we do environmental studies by observing the wave patterns of the ocean and things like that. We have a wing that develops sensors. We have a vessel management cell where we have 4 vessels that can, one of the vessels that can go all the way up to Antarctica. We handle cruises yearly. And also if you can see bottom middle, there is some visual where within hands something is burning like a, camphor, karpuram. So basically it is called gas hydrate, which is available in the Krishna Delta Basin in AP. So we are developing technology that can actually, that remotely operable vehicle can actually test the, what is it, soil quality at the depth. And also we are developing technology where we can extract cores so that we can quantify what is the extent to which we have the reserves of these gas hydrates. Gas hydrate is nothing but solidified form of methane, which is available at around 21, around 4 degrees or 0 degrees centigrade. So that is available in huge quantities in the Krishna Delta Basin. Okay. And we also deal with ocean acoustics where we hear the sound, and we try to develop security based applications so that we can detect enemy crafts and things like that. We have an active marine biotechnology wing where we develop some of the applications for fisheries. One of the applications, the few of the applications that are very popular are fish aggregating devices that we developed. Basically, in the ocean, if we leave anything, we can see formation of green algae, that is nachu in Telugu, green algae. So that attracts fish. So technology wise, what we do is we install something in the middle of the ocean. There will be formation of this green algae. All the fish will be coming into that region. Then fishermen can go to that region and catch that fish. That is what we do in fish aggregating devices. And also we also work on fish cage technology where at 25 to 30 meter depth we deploy a cage, and we can either catch fish or we can actually grow fish in the cage so that fishermen can go to that region after regular intervals. They can extract whatever fish have developed, and they can make their livelihood easy. These are some of the things that we handle at NIOT level. Any questions? Okay, fine. I'll go on to the next topic. Uh, I will be handling 3 to 4 issues in detail. One of them is the low temperature thermal desalination plants that we are working on in the Lakshadweep Islands. Basically, if you see the ocean surface temperature is around 28 degrees. When you go to the beach, you will be able to see that temperature in the ocean on the surface. As you go deep in the ocean, the temperature of the water drops, and deepest parts of the ocean, you can see temperature at 4 degrees centigrade. At about 350-meter depth from the surface, you can get around 12-degree water. Okay. What we do is we have 2 applications at NIOT. One is based on basic Rankine cycle, where you operate a Carnot cycle, Rankine cycle between 28 degrees and 8 degrees. Okay. You use ammonia. You evaporate ammonia using 28-degree water, and evaporation will be happening at say 22 to 23 degrees centigrade. Okay. Now you with that energy you run a turbine and produce electricity. Okay. Now you have ammonia at 23 degrees. If I can condense it again and push it back, it will become a continuous cycle. So what we do is we go to a depth of around 1000 meters in the ocean where 8-degree water is available. So with 8-degree water, we will be condensing this 23-degree ammonia, and the condensation will be happening at around 13 degrees centigrade. Okay, so ammonia cycle will be operating between 23 degrees and 13 degrees. So I can run a power plant between these two temperatures and produce electricity without any external this thing. All I need to do is draw the water from the depth and also draw the surface water from the surface so that I can produce electricity. Okay. Typically, we are talking about for that temperature range around, I guess we will be working at around 2% efficiency, I think. And we were designing 1 megawatt 1 megawatt ocean thermal energy conversion barge mounted plant for this technology. So we had some difficulties. So as an offshoot of that technology, what we are doing right now is instead of going to 1000-meter depth, we are going to around 350-meter depth where 12-degree water is available. Okay. Now try to listen carefully. I have water, okay, at 28 degrees. Water can boil at 100 degrees at 1 atmospheric pressure. If I lower the pressure to about room temperature, 21 degrees, water boils at 25 millibar pressure. So that means 28-degree water without any external heating, I can boil it at 21 degrees if I can put it in vacuum. Now I will have 21-degree vapor. Now, if I can condense it, I'll have fresh water without any heating or cooling. This is what we do in this low temperature thermal desalination. What we do is, I will evaporate surface water at say 27 millibar and 22 degrees. I will have 22-degree vapor. Okay. Then 22-degree vapor, I'll condense using 12-degree water from 350-meter depth. Okay. So with just three pumps, one to draw surface water, one to draw the deep sea cold water at 350-meter depth, and one to maintain vacuum in the system. I will be able to generate fresh water that is potable, so to say. That means you can drink it without any problem. It is better than normal groundwater that you get. Okay. The basic equipment that you need for this technology is you need a flash chamber where if you put water at that vacuum, you can evaporate immediately. So water will be allowed from surface to enter into this under vacuum conditions. Okay. This is called a vacuum flash chamber. Then vapor, once it is generated, it will be passed on to a shell and tube heat exchanger where one side it is vapor, the other side, the condenser will have around 1,000 tubes, cupronickel tubes, small tubes. Okay. The other side of the tubes is being fed by 12-degree water that is extracted from the sea, deep sea. Okay. Now, this is the shell and tube heat exchanger. Once vapor passes through it, I will get fresh water on the other side. Now, a vacuum pump is being maintained to maintain vacuum in flash chamber and vacuum system. I mean flash chamber and the condenser. And surface water will be drawn by one pump, and deep sea cold water will be drawn by one more pump that is installed in about 5-meter water depth. If you see the technology, all I need is access to that depth, 350-meter water depth. The Lakshadweep Islands, which are on the west coast of India, all these islands can have this depth within 400 to 700 meters from the shore, from the coast. So we initially installed one plant after our failures in the VOTEC. We initially installed one plant in Kavarati in 2005. That plant to this day is running with the local persons in the remote island to this day. Okay, we maintained it for 1 year. After that, we gave it to the local administration. So after that, looking at the performance of that plant, they came to us to install plants in the rest of the islands. We installed in two more islands in Minika and Agati in 2011. Right now, we are in the middle of installing 6 more plants in the region where one plant is completed. And 5 are in progress. Okay. And what is it? With the completion of these 6, we can say proudly say that all the 9 inhabited islands of Lakshadweep are being fed by the technology that we developed. Okay. I'll be briefly explaining the technology. What I would like to, since the audience is mixed audience, what I would like to, like the audience to go through is uh, look at the multidisciplinary aspect of the project and how we are integrating and how we are giving a product that can be taken by the common persons. Where if they demand, I have to install a plant. I have no other go because this is my technology and someone is demanding it. So I have to show it. Okay. So the plant has 3 components. One is the process components that I explained. For the ocean related aspects, I have to install the pumps in 5-meter water depth. So we install it in a caisson in 5-meter water depth. Okay. And in the caisson, the surface water around the caisson will be drawn as warm water. From the caisson, one pipe will go up to the 350-meter water depth. The pipe is around 1 kilometer long. Okay, and is made up of HDPE, single length HDPE pipe. Okay, and we take it to that depth and we draw water from there. All we need is provide the power for friction losses. Except for friction losses, we are not lifting any water. So pump power wise, to draw 100 liters of water, I may be using around 13 kilowatts of power. Okay. Like 150 liters per second flow for 1 kilometer long, I'll be using around 13 kilowatts of power. This is the pump power that I'm talking about. Okay, that completes the cold water side. Then I have a sump in 5-meter water depth. I need access to that. One bridge is needed from shore to the sump, and also plant building I have. So civil construction side, I have three components: one bridge, one sump, and one plant building. Okay. Then process is mechanical. The other part is ocean related, which combines with the oceanography side of the aspects. Then the cold water pipe that I am talking about is a single length pipe which has to withstand all the weather conditions like wave, current, okay, all these conditions. So it has to withstand that this thing. So we designed that cold water pipe in-house. All the entire plant is designed in-house, right from conception to design. Then we give it out as contract to the vendors. Then we will install, we will run the plant for 1 year. Then we will give the product to the vendors. This is our activity. If you say, what is my role in the project? Since I am mechanical, I'll be handling the mechanical side of the aspects. Okay. From here onwards, I guess the slides will go slightly faster. So I want to just give a break. I would love to have introduction, interaction. If you have any questions, please ask so that I can explain more. I cannot hear. Can the hello?
Friends, if you have any doubts or any queries related topic, because desalination is a major target for drinking water, not only islands, special metropolitan cities also. So about the technology, if you have any queries, you can ask expert with us. Utilize the opportunity.
Any questions that comes to mind will give me an opportunity to see in what way you are thinking. Accordingly, I will moderate the talk, rest of the talk also in those lines. No questions? So either my talk is completely not understood, or I am so clear that everyone understood it very clearly.
Everyone understand it very clear, sir. We will think like that.
Okay. Okay. So I'll be briefly describing what are the design intricacies in the project. So I'll be going component wise. In this slide, if you can see, what is it? There is a temperature profile that goes from surface to 200-meter water depth, where around 4 to 5 degree water can be expected. Okay, that is the temperature profile. Then the quality of the water that we produce. Actually, to be truthful, in a closed forum, we try very hard to add some more salts to it, because after boiling and then condensing, we don't find any salts in the water. Normally, by drinking water standards wise, up to 500 is the limit of drinking water. That means total dissolved solids in the drinking water, up to 500 ppm, you can drink the water. But as soon as it crosses some 60 ppm or so, your tongue can tell that this water is not so good. It is still drinkable, but it is not so good. The RO water that you get is of the order of some 50 to 180 ppm. We maintain all these plants at 200 to 200 ppm, but without doing anything, I can get 20 ppm water in this plant. I have to struggle very much to maintain 200 ppm water. Okay. Then at the bottom of this thing slide, you have a bridge, a building sort of thing, a sump in the middle of the screen. Then one small line is going to the deep sea, where relatively that is the pipe that I am talking about. Let me give you some idea of the sizes. Okay, the bridge that I am talking about, or access from shore to 5-meter water depth, depending on the island, we are talking about 800-meter long to uh, uh, 1.2 kilometer, I mean 280-meter long, 80-meter long to 280-meter long bridge. That is what we are talking about. Okay. Then it is a normal bridge. Why should a scientist talk about it? I'll come to that point a little bit. Okay. These islands are very remote. We don't have any access. The heaviest crane that is available in these islands is 6-ton crane that you can see normally, that yellow colored crane. Okay. That is the heaviest crane. So all my equipment should be lifted by that crane. If it is heavier than that, I have to take a crane also from mainland to these islands. So everything should be designed for that design parameters. Okay. Then the sump that I'm talking about is a low income category house. It is of that size. That means 30 feet uh, length to 24 feet width to 30 feet height. That means a 3-storied LIG house. Okay. This sump, the way we construct is, initially we will construct around 2.5 meters, because islands have deep sea access on one side, and on one side there is a lagoon where it is a very short depth. So 3 meters I will construct. This size can float if I push it in water. That is the way which I handle the weight of this structure. Okay, this floats by itself in water. So I will maintain that 2.5-meter height in such a way that for the depth available in that side of the island, this structure can float. Then I will take it to somewhat deeper portion, raise a little bit more. So I will keep on raising up to say 4.5 to 5-meter height. Then I will come to the other side where depth is available. The last portion of the sump will be installed in 5-meter water depth. So just before I sink it, I will raise it by 2 more meters so that it will clear water and it will come out by 2 more meters. So this complete 30 feet by 24 feet long structure we will be constructed in stages, around 5 stages. Okay, it will be constructed in water. We will be towing it like a boat to the to the actual site. Then we will position it at that place. Then we will construct some more, and then we will sink it, just to avoid the involvement of heavy duty cranes which can lift the structure that I am talking about. The final weight that we are handling in this structure is of the order of around 400 tons when it is completely constructed. You see, between the design requirement of I have to lift it and the actual execution of how we are doing it, if I can work sincerely in my topic, okay, I can cut down cost in various ways. This is the way in which we do research at NIOT. Okay. Now, the second part is the HDPE pipe, which I talked about. This is like 630 diameter outside pipe, outside diameter, and thickness is around 30 and it comes in 12-meter pieces. Each weld, it is a butt welding process where each weld will take around 3 hours. We'll grow it to 1 kilometer long. Then 1 kilometer, we attach some weights in the front and some weights in the back. We'll float it from shallow end to the deeper end. We'll align it in the position, lower the front end, then make the connections, then lower some weight to the back end so that it will go to the 350-meter water depth and sits there. This is the way in which we execute the deep sea cold water pipe, which by nature and by design, it is flexible. It can take its own shape. You see it has a shape of a bow, like inverted bow. Okay, it will respond to the ocean waves and it can take whatever shape it wants, so that design stresses are reduced in the pipe. It will take all the environmental loads. The Kavarati plant that we installed in 2005 is still working. Okay, and this plant is the only one of its type in the world that is working, that I can say proudly. These are some of the things. Kavarati we designed for 1 lakh liters per day. Typically, I am talking so much about it, no? The quantity that we are producing is hardly 10 water tankers per day. It is not more than that. Okay, we extract only 1% of the fresh water from the water that is pumped in. That is because we are not heating anything externally. We are using only solar energy that heats the surface water to 28 degrees. Okay, just because of that, our efficiency is only 1%. But on the other side, each meter cube, I am producing water at 8 units per meter cube. That means per 1000 liters water that is generated, I'm using 8 units of power. That is the only operational cost for this plant. Otherwise, all the equipment is supposed to run 24/7, and there is no absolutely minimal maintenance for these plants. Okay. In the new set of plants, we increased the capacity to 1.5 lakh liters per day. As an IoT, we demonstrated the technology up to 1 million liters per day capacity plant, that is barge mounted plant. Okay. And 1 million liters per day means this 10 water tankers will increase to 100 water tankers. Okay. When you see the desalination technology, one is the thermal desalination that I am talking about, where we are working with naturally available water since we cannot heat water. That is because of Indian economics. When you go to Gulf, they have oil or petrol to heat water. They will heat up to say 85 degrees, and instead of one stage where after 85 using only one condenser, they use a 5-stage desalination where in stages the temperature will come down, and there are plants that can work up to 100 1,000 meter cube per day freshwater generation capacity. When you go to multi-stage desalination and multi-stage flashing process, that are thermal process being operated in Gulf. Okay, this is the thermal desalination field as far as thermal desalination is concerned in the worldwide. Then the other desalination that you generally hear is the membrane-based desalination. There you pass water through a membrane, and what is it? Because of the reverse osmosis, on the high pressure side, salt will be there. On the low pressure side, the pure liquid will go. So I can extract water. This is what you see in your domestic reverse osmosis based plants. Normally, reverse osmosis plants take around 4 units of power per 1 meter cube. That means 1,000 liters. That is the power consumption capacity of these plants. Then if you see MSF and MED, where I use oil to heat water, they also take around 5 to 6 units of power per meter cube. The low temperature thermal desalination that I'm talking about, at the scale of uh, 10 water tankers per day, we are achieving what is it, 8 units per meter cube. But I don't have to heat water. And at the scale of around 1,000 or 10,000 meter cube per day, we will be achieving around 6 units of power. This is the way in which the power consumption will go. But low temperature, there is no maintenance. When you come to RO, you have to change the RO filters, which will cost 25% of the project cost every 2 years. That is the way in which the market is there. Now, any questions up to this part?
Sir, no, sir, no, sir.
No? Okay. Uh, okay, I will try to speed up. Then what research can I do? Okay. One is how is the water evaporating? Basically, if you see that research, we will be talking about, it is very similar to the ejector that I have in the diesel engines. Okay, we have spark ignition in petrol-based, what is it, combustion engines. Okay, and we have compression ignition when you come to diesel-based engines. The research-wise, what we are talking about is pretty much similar to the diesel ejector-based mechanics in the flash evaporation process. But instead of going all the way, what we do is we want to see what is the vapor flow regime, and how vapor can take water particles from the seawater, okay, and go to the condenser side so that TDS is increasing. So how do I restrict that entrainment of seawater droplets along with the vapor so that I can improve the quality of water? Okay, what we are technology wise, what we are doing is, I am talking about island based desalination where the temperature difference is available around 600 meters to 900 meters from the shore. When you come to mainland, you have to go around 40 kilometers from the mainland in southern region, and 120 kilometers from the mainland in the northern region to get the same temperature difference. So there you are talking about a barge mounted plant where entire plant is there in the barge. You generate water, you take fresh water and transport it. Like for Chennai, we used to transport from somewhere in the south. Same thing, you transport in water vessels and bring it and you can drink it. So this is where that is one more aspect. The second aspect is I have to go 800 meters and go 400-meter depth to get that 16 degrees delta T. That means 28 degrees and 12 degrees. When you see any power plant, I have surface water at 28 degrees. Any coal-fired thermal power plant, it ejects water from its system at 8 degrees above ambient if the plant is efficient. If the plant is old, it will eject at 10 degrees above ambient. That means my temperature difference is 8 to 10 degrees when I come to any uh, coal-fired thermal power plant. You can demonstrate the same technology in the thermal power plant also, where you can typically address the boiler quality water requirement that is needed for the power plant. Okay, so only thing is the entire plant should be integrated with the thermal power plant at the design stages. There you are talking about only two modules, two more pumps, okay, three more pumps, then one evaporator, and one more condenser, so that you can cool this water. When you see this power plant, actually environmentally you cannot eject this water at 10 degrees above ambient. So all the power plants have a mandate to cool it in some channel and then leave the water into sea at 5 degrees above ambient. Using the technology, you can directly produce some drinking quality water and also at the same time cool the water to that requirement of 5 degree above ambient. We demonstrated this technology in North Chennai thermal power plant. Okay. And also we are in the process of establishing one more plant in Tuticorin thermal power station, where we are producing somewhere around 2 million liters per day capacity, where 1 million liters per day is boiler quality water. Okay. This is some study on how the vapor flows in the flash chamber. Okay. Then this is a study on how water droplets get entrained along with the vapor. Okay. And there is something called as a demister. Then how do you separate it? How do you separate the water particles so that you can make the quality of water, improve the quality of water? These are some of the studies. Then what is it? This is the droplet study, where if you leave droplets in the middle of the jet, how the droplets will go to the other side. This is a computational study on that. Okay, this is the deep sea water, deep sea cold water pipe. Okay, then uh, this is the actual plant that is installed in Kalpeni, one of our latest plants. Okay, this is the plant, Kalpeni plant, again, when we produced water in the January of last year. Okay, these are the marine structures that we use. I already explained in detail. This is the what is it, bridge and the sump. Even some of the piers that come after the breaker, that means wave breaks after 1 meter depth in the ocean. After the breaker, you cannot freely work in the depth. So we, apart from the sump where we construct it in stages, even the foundation for the bridge also we construct in stages. That means we put a table in the middle of in the water. Okay, the table will be breaking the water surface. Then we pour concrete on the table so that entire foundation for the pier is cast there. Then you raise the height of the pier so that after installation it will break the water surface. then we will maintain the weight of the spear in such a way that I can lift with chain pulley blocks. Once it is set, I will lift this foundation, remove the table and lower it. So this is a gravity foundation where up to say 100 meters in typically 100 meters of a 200-meter long pier. Okay, the foundation is done using this technology. The other area we directly drive piles into the soil. Okay, this is the sump that I am talking about, towing, like casting, then construction in stages, towing and things like that. To give you an idea, basically the figure that you see, it is like one-storied house, my house, okay, is floating in water where top 400 is visible to you as of now. That is the figure that you are seeing. This is a circular sump. So we design the entire thing in such a way that for that water pressure, the concrete that we pour can take whatever loads that are coming. These are the piers. Okay, this is the piling that we do. These are the piles that we are handling in one of the 6 island projects. This is the stages of the sump and sump stability. Then what is it for various waves, how will it respond, and while towing, how will it respond? These are some of the studies that we do on the sump. This is the towing analysis for the sump. Okay, then this is the in place stability analysis of the sump, where we check for overturning and sliding, and accordingly we will provide rock anchors for the existing condition of the seabed. Okay, this is a numerical study on the sump. These are some of the equations. Then these are some of the results. Okay, then how do I design these plants? For various temperatures, that is the temperature difference. These are the equipment. For various capacities, the basic design equation is what is the heat lost by warm water, what is the heat being gained by vapor, and what is the heat being gained by cold water. Then what is the flow that is needed for the temperature difference that I am working on. Then accordingly, what is the flow rate that I need to maintain. Okay. Then for that flow rate, what is the size of the condenser, what is the size of the flash chamber, then vacuum, how to design that vacuum system. Okay, what is the load of that vacuum system. These are the typical things that we go through in the design. For various capacities, we went through the design. Then any questions up to this part? Hello.
Sir, tell me, sir.
Any questions up to this part?
No, sir. No, sir.
Am I too fast? Am I too fast?
No, sir. No, sir. No, sir.
Are you able to understand?
Yes, sir. Yes, sir. Clearly, sir.
Okay. Then the next part that I am handling is for remote villages, coastal villages. Okay. If you see whatever I am talking about, it talks about a temperature difference, right? I talked about all the power plants also. Okay. Then I'm also talking about working with a technology where it is useful for our public and for our economics. Okay. What I'm going to talk about in the next few slides is this temperature difference is not available except at few places like a power plant or remote island or anything like that. If I go to any coastal village, for various reasons, even though it is by the side of the sea, the coastal village may not have proper drinking water. There are a lot of villages like that. So what we have is a solar-based multi-effect desalination plant for coastal village, where the temperature difference, I am getting it using by heating the water using sun rays. There is something called as solar collectors, where you concentrate the available solar energy to heat the surface water to up to 80 degrees centigrade also. 80 degrees centigrade, some of the solar collectors can give you water at a pressure of, at a temperature of 120 degrees centigrade and 6 bar pressure. Okay, a normal solar collector, whatever is available in our rooftop geysers, no, that are available commercially, that can give you water at even at 65 degrees centigrade. Okay, now the same delta T where I am talking about 28 and 12, my cold water temperature now becomes surface water that is available at 28 degrees. Okay, then if I can heat the water using a solar collector, I can utilize the same technology for a remote island, where if I can beat the economics and make say that for the remote village it is economical, they can happily use it. So this is the way in which the next few slides will go. Okay, what we are doing is, there is Vivekananda Kendra in near Kanyakumari. We demonstrated a solar-based desalination plant with a capacity of 10,000 liters per day. That means hardly one water tanker per day. Okay, but this one water tanker, it is completely coming from only solar. Nothing, no pumps are there. The pumps that we are talking about is at the most 1 HP pumps for both, what is it, 1 or 2 HP pumps for drawing surface water and giving it to vacuum system, and what is it, the flash evaporator. Okay, so what we do is, whatever I am talking about, people do in the Gulf, where they heat water and use multi-stage, multi-effect desalination. We use it in 4 effects, where from 65 degrees we come to around 42 degrees. That means we use around 22 degrees of heat. Okay, for each 5.8 degrees for water, because of the CP and latent heat relation, I can get only 5.8 for every 5.8 degrees, I can get only 1% of fresh water. So for this plant, since I am using around 20 degrees, I'll be working at around 4% efficiency. For every 100 liters, I'll get 4 liters of fresh water. We demonstrated this plant where multi-stage multi-effect desalination is being used. Okay, and solar collectors are used for heating water. Okay, and with 2 pumps that are working, we are giving the water to Vivekananda Kendra. But this technology can be used in any of your coastal villages. uh, we have to work on little bit, because funding has to be coming from a government body, where there is a mandate to provide for remote coastal villages. The running part can be handled using community fees. For providing this water, you have to charge some fees. So that fees will be possible to what is it, to maintain the plant in terms of annual maintenance, or one operator that is needed to maintain this plant. Okay, with this mode, you are talking about what is it, around 7 crore rupees for installing 50,000 liters per day, around 1.5 crore rupees for installing uh, uh, 1,000 liters per day capacity plant. Okay, but maintenance, the local persons or local body should be able to take care. NIOT will be able to give assistance in terms of anything is needed, something went wrong, you have to maintain, what is it, replace the pump, you have to make some repair. We are doing the same thing in remote islands. But what I am trying to drive is, uh, one thing is a user has to come. Another aspect is I am providing a solution where any user, if he is interested, can take the solution and go forward. Okay, these are the solar collectors. A basic solar collector which is rugged and readily available in the market can give you a temperature of 65 degrees. Evacuated tube solar collector, which is medium efficiency, will give you a temperature of 80 degrees. The efficiency will increase. Okay, then there is something called as linear Fresnel collectors, where you have to maintain the surface very clean. You have to clean it every day. Okay, and it can give you water at 6 bar pressure, vapor at 6 bar pressure, so that the what is it economics will come down. You are talking about a bigger plant for a slightly lesser price, but cost also will be increasing exponentially for each of these technologies. Okay, these are typical areas that are needed. Cost of the solar collectors that we are talking about. Okay, the cost of plant I have already given. Okay, and what is it? This is the design for 10,000 liters per day capacity plant. Okay, the power wise, the bottom pie chart will give you what is the power that is required for various components, or what is it, the cost that is going in each and every component. That is what is given in the pie chart. The cost component for marine structures, multi-effect desalination, the solar collectors, and the pumps. Okay, typically if you see, desalination plant will take about 50% of the total cost. Then marine structures will take 20% of the cost. 15% will go to solar collectors, and 12% to the pumps. Cost per liter will come to around 0.47 when you consider the capital that I invested. Okay, and also what is it, I'm for the person who is installing, he is getting back the money after say 20 years. He will get back the money invested on the plant also, so that he can invest a new plant. And also a profit percentage of around 7% to 11% is involved. Okay, so around 47 paise per liter is the cost that we are talking about when you are talking about a 50,000 liters per day capacity plant that is being constructed without any intervention of government subsidy. Okay, any questions up to this part?
Sir, no, sir, no, sir.
Okay, the next topic that I'm talking about is somewhat current if you are following the news. Recently, Modi Sahab inaugurated a wind project in Gujarat. Okay. Okay, we are contributing in a small way or major way, in depending on the angle in which you are trying to see. Okay, so when you see wind energy, uh, land-based wind energy, the capacity is exhausted by all the land-based turbines that we installed in various regions. Okay, now you can install wherever land-based wind energy is available.
అయిపోయి కూడా తప్పించుకున్నావు ఫోన్ తప్పించుకున్నావు ఇంకేమంటుంది అబ్బా నాకేందో నాకు ఇంకా నేను సంబరం
What we are working on is a foundation for this wind energy. Okay. Hello. We are working on the foundations for these land-based wind energy. Typically for Gujarat site where we are talking about, the Gulf of Kutch and Kambat, the tide varies about 5 meters in the ocean. That means between low tide and high tide, there is a difference of 1.5 floors, okay, in the water level. So we have to have structures, these wind turbines are installed in 20-meter water depth. Okay, so typically we are talking about what are the ocean parameters that are available there, what is the geophysical condition, then how we can install a pier in that depth, and mostly these piers have to be piled. That means a steel structure has to be installed. So how can I pile these things? All these things are involved in the designing of these things. So we installed the foundations for these wind platforms, where for 2 years you have to measure the wind availability so that the project funding can be approved. So one structure was installed in near Jakau, Gulf of Kutch, okay, in 2018 or so. Another structure is installed in Gulf of Kambat near Pipau. Both these structures are installed in 20-meter water depth. Okay, and around 45 to 55-meter long, 1.2-meter diameter cylinder is installed as part of this. Okay, this pipe, 1.2-meter long diameter pipe, around 50-meter long. It is towed from Mumbai to Gujarat. Okay, it is piled at it is piled in 12 to 15-meter water depth. Okay, and a lidar is installed, and right now we are doing measurements. That is the research that we are doing as of now. Okay, for that we also collect wind speeds, the wave details. Then the actual research that we do is pile soil interaction, how the 50-meter long pipe will respond to various waves and things like that, waves and current loads. And so what is the thickness that is needed for this pipe? Okay, and because of the corrosion, what is the thickness that I can allow? All these things we will handle in the in the research that we do normally, typically. We are also installing one more uh, uh, wind turbine in one of the Lakshadweep Islands as part of this program. Apart from these two, we are also working on shore protection projects where we install caisson, the sump that I am talking about, a variant of that caisson in such a way that when you see typical profiles for our Indian Ocean, during one season coastal currents go from south to north. During another season they go from north to south, and erosion is observed in one of the seasons. So what we do is, wherever erosion is there, we install some structures under just below the water level, so that on one side it can trap the sand and reduce the erosion, and on the other side we are not completely blocking, so that by developing a beach on the south, we are not introducing erosion on the north side. So what we did is, we installed two such structures. One is near Pondicherry, where we installed 150-meter long caisson with a 150-meter long 150-meter base and 3-meter height. We installed this caisson, which weighs around 900 tons in Pondicherry, and we observed beach development as seen in the top corner of this slide. If you see, this is the beach before and after installing the the caisson. The same thing what we did is, in one of the coastal villages in Kadalur Periyakuppam, we installed a geosynthetic bag of height 3 meters. sorry, 1.2 meters in 2-meter water depth. So, and we filled it with sand. Once we do that, it is possible to trap the sand and develop the beach. So we demonstrated the project in Kadalur Perikuppam area. So basically the type of the research that we do here is the ocean related research, where if I install a particular this thing, how the wave rotates and how will it affect the erosion or sediment deposition. This is the research that we do. Okay, this brings an end to the topic. I can understand that most of the talking is from my side. I presented 3 topics where we are talking about, if you say renewable energy or desalination as part of the offshoot of that one, we are talking that. And also wind energy, what are the structures that we can design so that we can install wind turbines. And also beach restoration as an offshoot of both these renewable energy and coastal structures. This is the way in which I was trying to cover. If you have any open questions in the areas that I talked, or any general topics related to renewable energy, desalination, erosion, anything, I'll be happy to answer.
One doubt from organizing team itself, sir.
Yes, yes.
Actually, for the desalination, your investment cost you mentioned is too high.
Yeah, very good. It's a very good question. Now, I have also talked about the cost of energy that is needed for producing that water. The 8 units, 6 units and 4 units.
Yes.
Okay. RO plant, a typical RO plant, it costs around 4 units. Okay. Now, for every what is it, for every million liters that is generated, for every meter cube.
Yes.
Okay, there is a typical cost for the RO plant. Okay, now that is the installation cost that is needed. Every 2 years I have to change the membranes, so 25% of the project cost will go in the membranes. Okay,
Yes, sir.
so when you see what we did is, we are not saying that desalination is, low temperature thermal desalination is the whole and sole solution for any problem. We are not saying that. In some of the areas, it will be cheaper than RO. That is what we want to highlight. In some areas, like when you take these islands.
Yeah.
In these islands are remote. When you all these islands, we put up RO plants in 1990s. To this day, none of the RO plants is working, because once it is if some small sand particle enters that membrane, plant will stop working. Then the membranes have to go from mainland to the island, and some expert has to go there and change it. So typically, if you see from the user perspective, 3 days it will be working fine. Suddenly one fine morning, plant stops. You don't have drinking water. Then expert has to come. So it will take 1 month. Once they repair, it will work for 6 months. Then it will stop again. So it is a, what is it, site-based solution, what we are providing. Okay. Did I answer your question? We compared the price for the island environment. What we obtained is, typically when I load everything for the island desalination project, okay, the Agati plant that we installed comes to around 1.3 rupees per liter if I'm selling it for a profit of 7 rupees, 7%. Okay, for that profit range, whatever investment I am putting, if I sell each and every liter of water at 1.4 liters per 1.4 rupees per liter, I'll be getting 7% profit, where I'll get project cost in 10 years. Whatever I invested, I'll get it back in 10 years. Okay. Same
Okay.
thing if I go for RO plant, what we are getting is RO plant also, when we add all the maintenance aspects related to that one, it will be more or less the same cost, because every 4 years, no one will talk about this membrane replacement. So when we see anything for mainland, we don't recommend low temperature at all. If you have power plant, yes, we can handle two problems. So we recommend that power plant based desalination plant. Okay.
Yes.
Yes.
Any doubts from the audience? You can clarify your doubts from the expert. Well, because in my knowledge, science and engineering board research, SERAB, and DST, Solar Energy Research Initiative, these two bodies are giving funds related to solar-based desalination systems. So more scope of R&D funding also available for academic institutions, not
Yes.
other institutions. So you may utilize the expert knowledge. If you understand everything, means no problem. It is very good.
Typically, what we do at the institute is, if you have any MTech projects in these areas, we work as co-guides, so that we can give one of the problems that we are working on. If you see, there are a lot of aspects where I am already implementing some of the projects in the field, but I also have some of the research problems where I still have some doubts whether I can install something new, something better, and things like that. What we do is, we don't work on paper research. We work on application research, where anything that we work on, it will one day go into the field and we will implement it. So any topic you have, MTech project, PhD project, or something like that, we can work as co-guides also. And what is it? Finally, you along with the student will be working on a problem that is already implemented or in the process of implementing.
Yes, sir. Yes, sir. Yes, sir. We will definitely, sir. Why? Because in our department, solar separate R&D center is available.
Okay.
So we will keep on touch with you, sir.
Okay.
Yes, yes. Not only MTech projects, some R&D projects also we will use your expertise, sir.
Definitely.
Yes. So with this, I think from participant side, we are not received any questioning. I think they are, I think 4.5, continuously 3.5 hour lecture continued. One is lab visit and lecture, followed by the lecture. So from management side, organizing team side, I am myself Siva Reddy. I am expressing my deep thanks to our expert. Is a patient explanation. Why? Because whatever the work is taking place in the government side, why? Because National Institute of Ocean Technology is a authentic organization which is working on this desalination side. At least we came to know what is happening. Means based on that we will write the proposals, not from the scrap. Generally, education institutes means theoretical equations we are developing and we are writing proposals to the funding agency. Finally, from the funding agency, we are getting rejection. Why? Because this is already done by some other organization. So some base, I think from expert lecture, we understand some basic work already executed and commercially viable. From that, whatever the challenges is there, we will identify and we will work, sir. It is a great privilege for us, you as an expert lecturer. In future also, we are keep in touch with you, sir. Thank you, sir. Thank you very much, sir.
Thank you very much from my side, and I am thankful for the organizers to giving me an opportunity to interact with you. And thank you very much. In future, if you have any doubts on whatever I presented, or if you have any questions in any areas, you feel free to contact me. My contact details are available with
Yes, sir.
Siddha Reddy sir.
With us it is
Okay,
available, sir. Yes,
please feel free. Okay,
yes, sir.
we will be happy to interact with anyone. Actually, we work for public, so if someone is willing to take my work or my research, I'll be the most happiest. Thank you.
Yes, sir. Thank you, sir. Thank you, sir. Thank you for your kindness, sir.
Okay, thanks a lot.
Okay. Thank you, sir.
Okay.
With this, we are ending today's session. Tomorrow, sharp 10:30, our session will start. Thank you. Thank you very much.
Sir, okay, sir. Close చేయమంటారు సార్. Sir.
Close.
లౌడా వచ్చినట్లేదు.